getting this one, all the values. So linear regression is talking about continuous data set. So we have continuous data set in the decimal or in the numerical format. So we have 5 and 7.2, 7.5, or we have 8 and we have 10.23, we can have 3. These are the values given the regression. But when I talk about the logistic regression, so it's a it's all about the binary formats, either 0 or 1, right? Either male or female. It will talk about the either coin, the either it is head or tail, right? In such a way we will find some binary logistic regression problem, as there are only two possible outcomes, right? So I'm going to discuss this part here. I'm going to create one more code. That's the heading, and going to hit this one, just run. So above is a binary logistic regression problem. There are only two possible outcomes, right? If you find the logistic regression graph, you will find some like curve shape value, right? So this is the S curve. Here we have in the middle part, we have threshold value 0.5. Beyond, if any value falls beyond this graph, this will be class 1. Beyond this threshold value will be class 2, right? It justify in such a case, right? So green point shows, like, if you have data set. Okay, let me import the data set first. Okay, just wait. So I'm going to import this data set first. So I'm going to write the important pandas spd necessary files, and then for I mean for my this one for my visualization and everything, matplotlib, I'm going to import pyplot as plt, right? So I'm going also writing matplotlib inline, right? So I'm going to run all these commands, right? So my session has been included all these commands, right? So during the attention of this entire code logistic regression, we need to import the file. So what I'll do, I'll write pd.read underscore csv and just write the file name. So this file name is this one, last modified. Okay, insurance data.csv, right? So you will find rename it, courtesy, cancel, go there and just give the extension csv, right? So I'm going to run this code. So let me rename this as well, insurance data for logistic regression, right? So this is the next depicting. So for this representation, I am having only two columns, A's and bought. 0 is they didn't purchase the insurance policy, and 1 means they are purchasing the insurance policy, right? So when you go for these green points, if you will find along the y-axis, they are showing 1 every time, right? For the data set or the records, those are having 0, the candidates though didn't purchase the policy itself, they are representing by 0 on the x-axis, right? So here are the certain outcomes we will follow in the upcoming logistic regression. Those are given the two columns only, and this is the simplest way. Like, suppose I'm going to check courtesy and again cf.tail, TIL, and this is the last column, last 5 records, and only 27 records we have, right? And suppose you want to check df.sample, what are the like, let's say mpl sample. So this is the proper way, right? We don't have any output either apart from 0 and 1. So I want to check 5 samples. So I'll pass 5 integer inside the sample. So I'll hit run. So it will show the next sample every time, right? Now we can have the pattern or the relationship among the scatter plot and all. So I need to draw the scatter plot. So first we need to give the first parameter, that is the age, right? What is the age? Then we will need to give the second parameter, that is the target value, bot insurance. I'm going to give the bot insurance, and then I'm going to change the marker name, right? So this marker can have like plus sign, asterisk, or another chances, right? Apart from this, I can have the red color also, right? So I'm going to run this code. You can see this is looking like this curve. So all the ones coding are showing here, and all the zeros are showing on the horizon bottom line. So can we make this any regression like? Okay, so let me open a new tab, and okay, let me edit image. Can we edit? Yes. Suppose I'm going to mark up this line, and suppose I'm going to create any linear regression. So what is the linear regression part? Linear regression says if if data point is scattered along the x y axis, so you need to draw a line in such a way which is passing through all the data points, right? So this is the fundamental ethics given in the linear regression algorithm. So we are going to create a line which is passing through all the data points. So is it justified that we are having this line and all the data points are rotating around this line? So this won't give the justify answer, right? This won't give the proper value or proper range for your testing purpose, right? Because when you check this data point accuracy from this line, this would be very high. When you check the accuracy from this line to the least or the most most farthest point, then it will give the highest error. So this is not the actual way that we give the certain line to justify all these points, right? So inflating the entire linear regression, we are not going to create this line, right? We are not going to create a line passing through all these data points. So this was the drawback of our linear regression. So for overcome this linear regression, we remove the curve, or we just change the curve pattern, and then find what is the threshold value in between these two, and we will give the separate segment for these two classes, right? So in the same pattern, we will work accordingly. So from sklearn dot model underscore selection, I'm going to import this train underscore test underscore split, right? So this is the inbuilt function which will split my entire data set, right? And then again, I'm going to give my x train, right? And then x test, and then y train, and then y test, and then again this predefined function train test and split. Along with this, I'll give a parenthesis and pass the feature values only, right? So what is the feature value is, if you have more than one feature, so you will give entire data set. So within the A's, you will have this df dot, let me check is bot insurance. This is the target value. And what about the training part? So I'll give the train size. So train size would be 0.8, that is the 80%. So you can give test size also 0.2, that's the either choice. So 80% data set will go for the training, right? So here are our expectations in realistic manner that we are dividing entire data set into 80% to 20% ratio. So I'm going to run this code, which is going to split into 80% and 20% ratio, right? If you'll check the entire like test data set, you will find this one, right? If you'll check the shape of this data set, 6 comma 1, right? If I am going to check the shape of my train data set, so 21 comma 6, right? So 21 plus 6, I'm having 27, right? So you can see 26 is the last index value starting from 0, which means I'm having 27 records in my data set, right? If I go to the Google and for the 27 multiplication 0.8 will give around 21.6, right? So which is the 21 for training data set, right? If I'll check for 20% data set, so I'll multiply 27 with 0.2, which will give 5.4, which is around 6. So you can see 6 records are going with the test data set and 21 records are going with the this one training data set, right? So my partition is fine. I can go with the training data set. I can go for the model prediction and so on, right? For algorithm point of view, I can go for sklearn dot linear underscore model import and then logistic regression file. So this is the logistic regression folder, right? So from this entire library, I'm going to create one object which is inherited from logistic regression. So I'm going to run this code, right? So you will have to fit this model or the train my entire machine using model.fit, and I'll give first training part because I need to train my entire data set, and I'll train this data set over the wide train, right? So I'm going to run this code, right? So in the fraction of seconds, this is just running, right? So as far as logistic regression is concerned, so I can give the another C is equal to 1.0, which is the another parameter. And for class weight, VEIGST, I'm going to give nothing, right? And then dual is equal to first. I'll explain all these parameters in a while. Just let me write it down, or just let me predict the entire data set, entire fitting value. So for fit intercept is equal to true, I'm making it true, and that for intercept intercept underscore scaling is equal to 1, and then for maximum iteration, right? What should be the maximum? I put comma there. Yes. So maximum iteration would be 100. I need 100 iteration, and then for multi class, I'm going to make it 1, right? And then for number of jobs is equal to none. I'm going to make it none. And then for penalty is equal to 12. And then for random state underscore, I'm going to make it none. And then for solver, let me break it down here. Solver is equal to again 1, right? And then total accuracy or the total value will be 0.001, right? And then verbose is equal to 0, and then warm underscore start is equal to false, right? Let me run this code. It's successfully running, right? If I'll check this x test, so it's going to take this value, right? So this is how we these data set we have in the x test, right? So on the basis of this x test, I need to predict some value. So what I'll do, I'll go with the y predict. This is the user defined variable, and within the model dot predict, I'm going to pass my x test, which is consisting all these records, 6 records only, right? So I'm going to hit this one, and let me print it out. Right, can you see 0 1 1 0, right? If I'm going to print instead of x test, if I'm going to print y test, so it's giving actual values are 0 1 1. Here I'm having 0 1 1 0 1 0. 0 1 1, only the fourth value is incorrect, rest are correct. It's predicting correct for the rest value, right? So if you want to predict for model dot predict underscore probability. So what is the probability to to this testing data set, for this tested data set? So I'm going to check the probability. So 82% it is fine, right? Or 0.17, right? 0.92 for 0 and 1, right? So it's going with the higher value first. So it's going to 0 1. So for the third value, it's going to, so for the first case, it's having high probability, so it's showing the 0. For the second case, it's having high probability with the 1, so it's showing 1. For the third records, it's having high probability, so it's showing 1. And for the so fourth records is having high probability, it's predicting 1. And for the last records, it's having higher probability for 0 respectively, so it's showing 0 as a predicting class, right? So let's come back, roll back my function name. I'm going to copy this one. If you want to I mean check the probability or the entire explanation of this file, you just go to the right meaning of this code, right? What is the meaning of line wise, right? So inside the logistic regression, we have so many parameters, but we must know the exact definition, right? So, so a scikit library, right? It inverts the regularization. It is used for regularization. Must be positive smaller values specify stronger regularization, right? So this is first part is used for regularization. We are having this error part and everything, right? Anyone can explain regularization? What is the regularization part in the logistic regression? Anyone having any idea? No, no. So okay, regularization means we are going to like we are going to I mean means okay, check the reduce means comparatively with the error. So what is the error in our cases, right? So if you go to the regularization in logistic regression, so if you go for the decision boundary, right? So there are means the error boundation, right? You can not have the higher error in your model, right? How much error it is showing, right? So how to predict this error? Because you can see out of these records prediction 1 2 3 4 5 6, it's showing the third last as a false. So this is the error in our model. So what is the error? So out of the 1 upon 6, right? If I'll give 1 upon 6, right? out of the 6 only one showing error, so I'll give 0.16 or 0.2. My model is showing 0 means 16.67% error, right? Why? Because uh, out of 6 records it's showing only one false, right? So this is the error in my records. This is the error ratio. So I will find error ratio. So 1 upon 6 is 0.17 something. So I would give uh, this model is showing 16.67 error. But we have some theoretical operation, some target value and some classification boundary for the same. So this is relevant to the finding the regularization and mathematical background, right? You will study in the detail, right? We will discuss in the upcoming classes, upcoming sessions, right? When we have class weight, so optional dictionary or balanced. So this is the optional dictionary or the balanced one. If not given, all classes are supposed to have weight 1, right? You can give the weight for each target value or each a certain features name also, right? When we go for the dual or primary formulation, it is only implemented for I2 penalty. So there is two kind of regulation. One is L1 and one is L2 regulation, right? So this is again the dual formulation when you have the L2 penalty, L2 regulation again, right? So in interception, so when fit transformation is true, interception x becomes x interception this one, right? Interception means like this is the graph, and we have the y interception over the particular graph. So this is the interception part. Multi-iteration, maximum number of iteration token to solver, and multi-class method to handle multi-class classification problem can have one rest and multinomial logistic regression. Number of CPU cores, right? To run this job, how many CPU do you required, right? So empowering the software developers, you need multiple CPU at a time. You need parallel processing. So in that case, you can give the number of jobs more than one, right? But we have only one CPU here, so we are giving only none, like it will use only one CPU core. If you want to use TPU, which is using multiple jobs, right? Multiple processors in a single time period, and GPU. So then you can give n jobs is equal to 10 or n underscore jobs is equal to 7 and so on, right? So penalty again can be L1 and L2, elastic and so on, right? Type of regularization. Random stage, so it's a serial number generated to use shuffling the data. So right, we are shuffling the data set, but when we need certain random state only, so this is the probability state, okay? So how to define the random state? Okay, so I had shown the sample 5 means if you hit run this sample 5, so this is giving this probability, right? If you're running this code again, can you remember 1326? So I'll give this combination, let's say this combination called serial number 1, right? This combination, I have given a serial number 1 for this combination. Now I'm running this code, right? Can you see now 13 5 12 is replaced with 10 4 12. I'm giving this serial number as a serial number 2 for this probability combination, right? I'm running this code again. Now this is 17 26 16. So this is another serial number, another probability and code, right? So I'll call it serial number 2. Now again I'm going to run this code. This is showing the another combination. So for this combination, I'll give another serial number 4, right? So are you getting this point? How we are assigning these serial 4 and serial 5? So this is nothing actually random state, right? So if you give random state in some other codes, you will give sign random state is equal to 40, right? Okay, so Google random state 40 420, right? in so many codes they have given logistic and regression. They had given, can you see, random test spade housing testing, random state is equal to 40. So random state 42 means you are giving this serial number 42 every time, right? I need this combination serial 3 only every time, this combination only. So I'll give this serial number 3. I'll pass with this parameter along with this comma, although it will not work, but I'm giving just an example. Then you need this serial number 3 every time in your code by shuffling the data. So you will give another parameter that is called serial number 3, and in this case you will find this combination only for your shuffleness, right? So this is the discussion part of some potential drawback of this random data set. We are going to shuffle the data set, but every time we are getting a different combination, permutation and combination. But if you need certain combination only, then you have this random state 42 or any other integer name you can give. It hardly matters. But what is the purpose of this random state, you must keep in mind. Interview may ask that what is the random state is equal to 42, or why do we give here in our code, right? Are you getting my point? So this is the reason we give random state everywhere in our code. Let me check it out in other code, right? So here in the some other code also you can give the classification and random state. Can you see random state is equal to question mark, right? You cannot give it like question mark. You will have to give some numerical value, but you must understand the aspect value, the illustration part of this code. What is the random state actually? Solver, again, algorithm to use solver program, Newton, and total tolerance of stopping criteria, verbose, enable verbose output, right? Warm state, reuse the solution and previous call to fit, and otherwise just erase the previous solution, right? It is going to erase the previous solution and so on, right? So now we can check the other parameters also, right? Suppose we have model dot coef and coefficient, right? So this is the coefficient of my gradient, and now I'm going to check model dot intercept. So this is having minus 5.313, right? So can we define some user define? Okay, do we have, this is how we can give the entire, oh, okay, let me go for the let me move to the mathematical background, right? Mathematical logistic regression, maths behind logistic regression, right? So what is the actual expression, actual meaning of this entire value, right? Okay, open image, new type. Can you see this function? This is e raised to power x upon 1 plus e raised to power x, right? This is the function to create this line, right? How to check this function name? Okay, I'm going to create e raised to the power exponential of uh, let's say 2, right? Divide by 1 plus exp exponential of 2 again. So is it the correct explanation, a correct meaning of this fx? If you will put f of 2, you will, on the right hand side, you will write it e raised to power 2 upon 1 plus e raised to power 2. So I'm just finding the value of this and right hand side value, right? So this is the key role in enforcing to get the mathematical value. So I'm going to run this code, and you find it's a near about 0.88, almost 1, right? In case you will change this value to 200, right, and hit run, so you will find it's almost 1, right? In case I'll make it minus 200 in this expression, I'll find minus 200, run this code, it's almost 0. So this is 1.33, 10 is to power minus 87. If I'll check for minus 2 only, so I'll find some either value. It's almost 0.1, right? 0.12 you would say. But approximately you will say the value is almost 1. So the expression is approaching either 1 or 0. Can you illustrate this thing? You can check by yourself also. I'm copying this code and sending in the chat box. You can check any value inside this expression and Google it, right? Like this expression will show any value either approaching to 0 or 1. Here are some practical steps we can take to address this issue. The logistic regression is approaching 1 or 0, right? This is the mathematical background of this logistic regression, right? And how to like, can we go with the equation part? So what is the equation of logistic regression, right? Can you see? This is the logistic regression or the coefficient part. If you go with the coefficient part, right? This is the curve. This is how we are creating the curve, right? Right? So obviously this exponential is xb, x1 and x2 and x3, right? Binary logistic regression model is represented by this one, e raised to power 1. And can anyone explain what is the beta 1, beta 0 and what is the x1 and x2 here? What is beta 0 and beta 1, x1 and x2 here in this expression, or in this case log of this one upon theta 0 theta 1. What is the theta 1, x1 and x2? Can anyone explain? Okay, so let me explain. PINT. So we have this point of view x1, right, plus beta 1 plus x2, right? So this can be rewrite as, in some equation, in some other resources you will find as beta 0 plus beta 1 into x1, right? So this is the fx. This is the equation of my this one of my data set, right? So beta 0 is nothing. Beta 0 is actually coefficient, right? We can get the some coefficient from the given data set, and beta 1 is also another coefficient, right? And what are the x1 here? X1 is age factor. This is the independent parameter, right? And what is the fx here? Fx is dependent parameter, or I would say this is the insurance person buy the insurance policy or not. Insurance buyer, right? He is going to buy my policy or not, right? It should be 0, either 0 or 1. Am I clear? So dependent variable on the left hand side, we have y, right? Beta 0 coefficient, we need to find out using mathematical operation. Beta 1, again, another coefficient. And x1, we have A's factor. So every records, if you find in this sheet, every records, it will be work as x1, x2, and x1, x1, and so on. 26, 45, 60, right? And what is the coefficient for this one? We have 0.44, right? What is the intercept? We have minus 5.33, right? So we have coefficient, right? So coefficient is this one. This one is the coefficient, right? And what is the intercept? Intercept is beta 0. This is the intercept part. I'll call it intercept, right? So this is the intercept part, right? So is there any issue